Chapter 5, Section 1. Chapter 5 is all about systems of equations. We'll get into what that means here in a second. But there's three ways that we'll look at on how you solve systems of equations. Today we're going to talk about the first method, which is solving systems of linear equations by graphing. So we got to graph some today. Solving systems of linear equations by graphing. First, let's talk about what a system of equations is. A system of linear equations is a set of two or more linear equations in the same variables. So two or more variables that contain the same variables, essentially. An example is shown below. X plus y equals 7. 2x minus 3y equals negative 11. How many equations are there? How many equations do we have there? Two. Do they have the same variables? Yes. So, this is a set of linear equations. When you get up into like Algebra 2, you'll deal with systems in three variables. So you'd have three equations. Today, and in Algebra 1, we're just going to deal with systems of equations with two variables. Any questions about what a system of linear equations is? A solution of a system of linear equations in two variables is an ordered pair, so an x value and y value, an ordered pair, that is a solution of each equation in the system. So in order for an ordered pair to be a solution to my system of equations, it has to be a solution for both of my equations. Not just one or the other, but both of them. Any questions about that? Okay, I'll give you guys some time to write. Example 1 wants us to tell whether the ordered pair is a solution of the system of linear equations or not. Okay? So letter A gives us an ordered pair of 2, 5, and then it gives us a system of equations. X plus y equals 7, 2x minus 3y equals negative 11. So it wants us to check to see if 2, 5 is a solution of this system. Any ideas how I'm going to do that?
Plug in for x and y.
Plug what in for x, plug what in for y?
5.
Well, which specifically? Plug which number in for x and which number in for y?
5 for y and x for 2.
Very good. I'm going to plug 2 in for x, 5 in for y, because an ordered pair is written as x, y, correct? So 2 is my x value, 5 is my y value. Okay? Which equation am I checking here? X plus y equals 7 or 2x minus 3y equals negative 11? Which one do I have to check? Both. Because in order for an ordered pair to be a solution to my system, it has to be a solution for each equation in the system. So I've got to check it for both equations. Does that make sense? So, we'll plug it into x plus y equals 7 first. Replace my x with 2. Replace my y with 5. And now I'm working down both sides of the equation to see if I get a true statement or a false statement. So on the left side, to simplify that, I'm going to do 2 plus 5. What's 2 plus 5? 7. Is there anything else I need to do to the right? No, the right is simplified as far as it'll go. 7 equals 7. Is that a true or false statement? True. So, is 2, 5 a solution to my first equation? Yeah, because I plugged it in and I got a true statement. Does that make sense? Does that mean it's automatically a solution for my whole system? No, it's got to also be true for my next equation as well. Everyone okay with that concept? So let's plug in to 2x minus 3y equals negative 11 now. Once again, replace the x with 2. Replace the y with 5. And we'll work down both sides of the equation. Any questions how I've plugged in? Are we okay plugging it? Okay, on the left side, there's quite a bit of simplifying to do. What's 2 times 2? 4. What's negative 3 times 5? Negative 15. There's nothing to do on the right, so I just bring it down along for the right. What's 4 minus 15? What? Negative 11. Can I do any more simplifying? No, I get negative 11 equals negative 11. Is that a true or false statement? True. So, is 2 comma 5 a solution to my second equation? Yes, it is. I plug it in, I get a true statement. So if it gives me a true statement and it's a solution for both of my equations, I can say that yes, this ordered pair is a solution to my system of equations. So I would say 2 comma 5 is a solution of the system. Any questions on how we got that for letter A? Any confusion about that? Does everyone understand what it means for an ordered pair to be a solution of a system of equations? It's got to be a solution for both equations. Can I move to letter B? Okay, the ordered pair is negative 2 comma 0. The equations are y equals negative 2x minus 4, y equal x plus 4. What's my x value? Do what? Negative 2. What's my y value? 0. So in our first equation, I'm going to replace the y with 0. I'm going to replace the x with negative 2. And now we're going to work down both sides of our equation. Left side's already worked out for me. What's negative 2 times negative 2? Positive 4. And what's 4 minus 4? 0. 0 equals 0. Is that true or false?
Yeah.
That's true. So my ordered pair is a solution of my first equation. Right? Bless you. Does that automatically mean that it's a solution of my system? No, I also have to check my second equation. So once again, replace 0, y with 0. Replace x with negative 2. Work down both sides. Negative 2 plus 4 gives me 2. That's all the simplifying I can do on either side. I get the statement 0 equals 2. Is that true or false? False. 0 does not equal 2. So, is my ordered pair a solution of equation 2? No. So since it's not a solution of one of my equations, is it a solution to my system? No. So I'll say negative 2, 0 is not a solution of the system. Any questions on example 1A or B? Everyone understand how we got that? Everyone understands what it means for an ordered pair to be a solution to my system of equations. All right, can I move on? No? Okay, I'll give you a little more time. So when we're talking about systems of equations, our solution is going to be an ordered pair, an x value, and a y value. So keep that in mind as we're solving our systems of equations using our multiple methods. Okay? Okay, let's move on. So let's talk about solving a system of equation by graphing. The solution of a system of linear equations is the point of intersection of the graphs of the equations. Does everyone know what the word intersection means? If two lines intersect, That's the point where they're crossing, right? So, the solution of a system of equations is where the two lines cross each other, where they intersect each other. Okay? So, solving a system of linear equations by graphing, I would write these steps down if I were you. Step 1, graph each equation in the same coordinate plane. So, graph both lines. Step 2, estimate the point of intersection. Step 3, check the point from step 2 by substituting for x and y in each equation of the original system, just like we did on example 1. So graph the lines, wherever they intersect, that's your solution. Pretty straightforward, I feel like. Let me ask you this. Do all lines intersect at one point? No. Why not? How so? Parallel lines, what? What about parallel lines? They don't ever intersect, right? So let's say you get a system of equations that are parallel lines, and you're looking for the point of intersection, but they never intersect. What do you think your answer would be? So what would we say? What phrase do we use? There's a symbol for it as well. No solution. So if I get a set or a system of equations that's parallel lines, we're looking for the point of intersection. They're never going to intersect because they're parallel. So I would say no solution. There's never going to be a point where they intersect. Does that make sense? Let's say my two lines turn out to be the same line. So both lines would be pretty much just laying on top of one another. Where are they intersecting? If it's two lines that are on the same. Infinitely many solutions, because they're intersecting at every single point because they're the same line. Okay? Can I move on, or are we still writing? Okay, give you a little more time. How do you know if you're going to have parallel lines before you even graph? Now the same ordered pair.
They're the same reciprocal.
No. Same slope, right? If I see that my two lines have the same slope, I know they're going to be parallel, right? If they have the same slope and the same y-intercept, I know they're going to be the same exact line, so I know I'm going to have infinitely many solutions. Okay? If you haven't gotten all these steps, this is directly from the textbook. I do post my notes to Canvas, so if you did not get all these steps written down, you can go back and do that some other time. Example 2. Solve the system of linear equations by graphing. So I have y equals negative 2x plus 5, y equals 4x minus 1. What form do I want my equations in to easily graph? Slope-intercept form is probably going to be the easiest method. Okay? So, if your equations are not in slope-intercept form, what are you going to have to do before you graph? Put them in slope-intercept form by solving for y, getting y by itself. That's probably going to be the easiest way for us to graph these. Okay? Are our two equations already in slope-intercept form for us? Yes, they are. So, let's go ahead and graph them. Equation 1. What's my slope? Negative 2. I'm going to put negative 2 over 1 for graphing purposes. And what's my y-intercept on equation 1? 5. Everyone okay identifying the slope and y-intercept from an equation when y is by itself? Okay? Let's go ahead and graph equation 1 right now. What do I need to graph first? Y-intercept. In order to get more points using my slope, I need a good starting point. We already know one of our ordered pairs is going to be 0, 5, because that's my y-intercept. So I'm going to graph 0, 5 first. Go up 5 on the y-axis. There's my starting point. Slope is rise over run. So vertical movement over my horizontal movement. We got a -2 over a +1. So from my starting point, which two directions am I going to go if it's -2 over +1? Down 2, right 1. Negative up top means I'm going down. Positive in the bottom means I'm going right. So from the y-intercept of 5, I'm going down 2, right 1, putting a point. I'm going to keep doing that till I run out of room. If I want to get more points to the left of my y-axis, what do I need to do? I can change the signs of both my numerator and denominator and go the two completely opposite directions. Up 2, left 1. Connect my points, draw my arrows on my line. Questions how I graphed equation 1. Now, I need to graph equation 2. I'm still on step 1 of my steps to solving by graphing, correct? I've got to graph both equations on the same coordinate plane. So equation 2. What's my slope here? 4 over 1. What's my y-intercept? -1. What do I need to graph first? My y-intercept of -1. It's going to go to -1 on my y-axis. +4 over +1. Which two directions am I going to go? Up 4, right 1. From my y-intercept. 1, 2, 3, 4, 1. That'd be this point right here. 1, 2, 3, 4, 1. 1, 2, 3. All right, I can't go any more that direction. Once again, I can change both my signs, go the two complete opposite directions, go down 4, left 1 now. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Connect your points. Put your arrows on your line. Are these parallel lines? No, they're obviously intersecting somewhere, right? So, the point where they are intersecting, that is my solution. Okay? So where are these two lines connect or intersecting? What ordered pair would that be? 1, 3. Everyone see that? So 1, 3 would be my solution. Any questions how I got that? What's a surefire way to test to see if that is our actual solution? Plug it in just like we did on example 1. I'd have to plug it in for both of my equations. Everyone okay with that? If you plug it in right now, we get 3 equals -2 times 1 plus 5. -2 times 1 is -2. -2 plus 5 is 3. 3 does equal 3. It works for my first equation. And it does work for equation 2 as well. Are there any questions on our example here? To solve by graphing, graph them on the same graph. Wherever they intersect is your solution. We okay with that? Can I erase? Okay, let's say our equation 1 was -2x plus 5. Let's say our equation 2 was y equals negative 2x minus 1. I should have just left my equation 1 graphed on there. So there's our equation 1. We already graphed it. Equation 2, you probably see where I'm going with this. What kind of lines are these going to be? Parallel. Why are they parallel? They have the same exact slope. Does everyone see that? If I graph them, they're going to go on forever and ever and ever and never intersect. Graph my two lines on the same coordinate plane. The point where they intersect is my solution. If they never intersect, then I'm going to have no solution. Does that make sense? They're never going to intersect, so I don't have any solution ever for this system. You okay understanding that? If I get parallel lines, I've got no solution. Questions? Lastly, real quick, can I erase this? Let's say my equation 2, it wasn't in slope-intercept form, but I got it in slope-intercept form, and it came out to be the same exact equation as equation 1. So, they're technically two different equations, so if I graph them, they're just going to be right on top of each other, right? So everyone see that they would be intersecting at every single point. So what would my answer be here? Infinitely many solutions. Everyone okay with that? I'm looking for the point of intersection. They're intersecting at every single point. These lines go on forever and ever and ever. So I have an infinite number of solutions. You could say all real numbers. Any questions about solving by graphing? How do we feel about it? Can I get a thumbs up, a thumbs down, or a thumbs to the side from people on how we feel about it? Thumbs up, you feel really good about it. Thumbs down, you feel bad about it. Thumbs to the side, I might need some more practice. Any questions if you have a thumbs to the side or a thumbs down? Anything I can help clarify? Okay, like I said, there's 3 ways to solve systems of equations. Today we talked about graphing. We'll stay in graphing for another day or 2, and then we'll go on to the next method and then the next method from there. We good? Here's your assignment. Page 231, numbers 2 through 22, evens. Page 231, numbers 2 through 22, evens. It's about 11 problems. Not too bad. Make sure you get the assignment written down. Make sure you put the correct heading on your paper. Name, date, period, assignment in the upper right-hand corner. You will have to graph some. So if you have your own graph paper, that's fine. Use that. I do have some graph paper over here for you to use. That way you're not drawing your own graphs. Okay? So please use some sort of graph paper to do the graphing ones. Are there any questions for me before I end my notes? All right.